Typically, I start a video with an introduction. I do my best to set the scene by explaining the problem space, by giving a context, by explaining the pain points, and so on and so forth. Today, I will do things a bit differently. I want to show a project in action right now because I believe it is amazing and I think it might change how we see and think about Kubernetes. So, no intro, no discussion, no context, nothing. At least not yet. Let me show you right away how it works and we'll speak about it later. Let me start by outputting kubectl version in YAML format. Now, there is a client version, that's kubectl, running on my laptop, and there is server version. That's the version of the Kubernetes cluster I'm currently connected to. Now, the only strange thing about it is that it's version 1.24. Right now, the latest would be 1.25, but outside that, there is nothing strange here, right? I have local kubectl client connected to remote cluster, right? So, it looks like a normal Kubernetes cluster, but it's not. It has special namespaces and it cannot run almost anything, at least not directly or out of the box. It cannot even run pods. Wow! Strange, right? You heard me. It cannot run pods. It cannot run your applications in that cluster. Now, that might sound like something pretty useless, right? You have a Kubernetes cluster that cannot run even pods. It cannot run containers. Well, it's quite the opposite. It is very, very, very useful. Or at least it can be very, very useful. It can change the way you see Kubernetes and it can help tremendously with the management of, well, anything. Now, the Kubernetes cluster I'm running right now is a special form of Kubernetes cluster. It comes from a project called KCP. And one of the things I can do, and I will explain later what it really does, but for now I will just do it. I will execute kubectl KCP because there is KCP plugin for kubectl, and I want to use the workspace called root staging, meaning the workspace which is a kind of a namespace at the root. And you can probably already guess by me saying at root means that actually we can have nested workspaces or nested namespaces of sorts, right? But we'll get to that later. What matters right now is that I switched to something called staging workspace. And what I'm going to do is deploy my application to this cluster, to the one that I said that cannot run applications, that cannot run pods or containers. I'm nevertheless going to instruct the cluster that cannot run containers to run my application, including a container. And I'm going to do that in the same way as I would instruct any other Kubernetes cluster. And I'm going to execute kubectl apply, and I'm going to use customize, and I'm going to apply something defined in customize base directory. Nothing fancy, nothing special. I'm trying to deploy my application to a cluster that cannot run applications. So that's actually strange. So let me switch to a different tab that has two K9s, which, by the way, K9 is a way how to provide the dashboard capabilities from a terminal. If you're not familiar with K9, check the video. Anyways, the one on the left side is called kind staging. That's my staging cluster. That's something completely independent of KCP that I was showing so far. And I have a third cluster called production, right? So right here, you see two real clusters, staging and production. So I'm going to go back to my previous tab and hit the enter key, which will create service deployment and ingress in KCP. Nothing directly related with staging or production. And once those resources are created, let me go back to the other two clusters, the tab with two clusters with K9s, and see what's going on. And over here, you can see that a pod, and you must trust me that other resources as well are now running in the staging cluster. So what happened? Well, the explanation is simple, even though what it does is not that simple. I'm using KCP as a management cluster. And through that, and through workspaces and some special commands, I'm instructing it, hey, if I deploy this, actually you should forward that. You should delegate those resources to this cluster and those resources to that cluster and so on and so forth. So I'm using KCP as a control plane, which in this case delegated and managed deployments in a completely different cluster, in this case, in the staging cluster. And it is doing that through workspaces, which you saw previously, right? I can decide which workspace is delegated to which cluster or which clusters and quite a few other things. So let me switch to the production workspace by saying kubectl KCP, I want you to use workspace called root:production. And then I'm going to execute the same command as before with kubectl apply customize with the directory customize base and create the same resources, but in this case, inside the KCP cluster in a different workspace, in the workspace production. Now, if I go back to the tab with K9s, you can see that now in the production cluster, we have some resources running. So by me instructing KCP to use a different workspace, KCP knew that it should run those resources, forward those resources, and monitor those resources, and do whatever needs to be done for my application to run in the production cluster. Now, if I go back to KCP and say something like, hey, kubectl, give me all the deployments, you can see that from the KCP perspective, the deployment silly demo is there, right? So that's strange, right? Because I already said KCP cannot run deployments, it cannot run pods, it cannot do any of the typical stuff that we do in Kubernetes clusters, yet I applied, among other things, a deployment, and I can retrieve that deployment. But that's only an illusion. That deployment, nor the replica set created from that deployment, nor the pod, nor any of the other things are really running in KCP. KCP is just managing those resources. And it is not only delegating creation of those resources to other clusters, in this case, staging and production, but also monitoring the status of resources in those clusters. So what am I getting with something like that? Well, I'm getting a control plane. I'm getting a single entry point that I can use as if it is a normal Kubernetes cluster, except that from that entry point, from KCP, I can manage any number of clusters and any number of resources spread across any number of data centers and so on and so forth. It is truly a control plane that manages resources through workspaces. Now, going back to those deployments, I said before that KCP doesn't know about typical Kubernetes resources like deployments, pods, and so on and so forth. But what I can do, and what I already did during the setup phase, by the way, you can reproduce everything I did, including the setup phase, by going to the gist and copying and pasting. Anyways, so what I did is that I imported some APIs. I created a workspace staging and said, hey, you are using this cluster. And by the way, I want you to import all the APIs, all the CRDs, everything from that cluster, and simulate as if you can manage those resources. So each of the workspaces can import all the APIs or some of the APIs, or whichever criteria you want to use from any number of clusters or the clusters that are connected to that workspace. On top of that, I could create API schemas even from scratch, right? Something specific to KCP. Now, creating or importing schemas and CRDs and what's not is slightly different in KCP because those resources in real clusters or normal, typical clusters are cluster scoped, right? So you cannot have two of the same CRDs in the cluster because they are on a cluster level. But in case of KCP, they are workspace scoped or namespaced of sorts, right? So I can have the workspace staging with certain CRDs and then production with the same CRDs or some other CRDs, right? Each workspace is almost like a cluster by itself, except that it is really delegating the work itself to some other clusters. Let me show you that in action, right? I'm going to go to the root workspace by executing kubectl kcp workspace use root. So now I'm at the very beginning of, or the root of the KCP cluster. And over there, if I execute something like kubectl KCP workspace 3, I get a tree-like structure. I can see that there is compute, production, and staging workspaces, which are kind of namespaces inside of the root workspace. Workspaces are more like models actually in the KCP cluster, and they're backed by workload clusters, right? So each of the workspaces is backed by one or more of the workload clusters. So we can, as I already mentioned, publish APIs in each specific workspace, and we can decide who can manage which type of resources. A workspace binds APIs from workload clusters. Those are the real clusters. It makes them accessible inside the logical cluster, which is KCP itself. From the user perspective, a workspace is equivalent to a cluster that manages other clusters. Each workspace is effectively a control plane. So when I said it previously that KCP is a control plane of sorts, it's more like a control plane of control planes, and each workspace is a control plane of a specific cluster. We can restrict user access to specific workspaces, which in turn can access only specific APIs on the workload clusters. So from security perspective, not only management, but security perspective, it gives us some really tangible benefits. So let me show you that in action, because I already created workspaces that you saw so far in the setup phase. So let me create a new one. I will say, hey, I want to create a workspace called all, and just enter the result. Don't ask me any questions. And you can see that workspace all is created. Next, I'm going to execute, let me execute the command first and then explain what's happening. So I'm going to execute kubectl KCP workload sync all, which is now misleading. That's the name of the workspace I created previously. Use this image and then output it to the file syncer all YAML. Now, what I want to really to do, I should have said, I want to create a new workspace from which I can manage not a specific cluster, but all my clusters. That's the goal, right? And right now I have a manifest. I have actually a workspace called all. I created it, and I have a manifest that I should apply to each of my clusters. So let me go to the other tab, the tab with K9s for both of the clusters. I'm going to stop K9s for the staging cluster, switch the context, make sure that I'm in a staging cluster by executing kubectl context, and then I'm going to apply syncer all YAML. So kubectl apply, file name is this one, and from now on, my real cluster, staging cluster, knows how to communicate with KCP and instructed KCP workspace to work with that cluster. And I'm going to repeat the same thing for production. So stop K9s, apply syncer all YAML, start K9s again. Now, what you will notice is that in both of those workload clusters, real clusters, the new namespace was created. That's a namespace where KCP will be applying some manifests. And we can control that as well, but for now there is no real need. What does matter is that we got new namespaces in those two clusters. So let me go back to the first tab, to the one where I control KCP, and I'm going to do two things. First of all, I'm going to execute kubectl KCP workspace. I want to use the root workspace called all, the one that I created a few minutes ago, and then I'm going to bind it to to all the clusters that happen to have the manifest applied. And that results in two placements created. And also API export. API exported all compute resources into this KCP cluster, this KCP workspace called all. So from now on, this workspace is bound to two of my clusters, staging and production. So you can probably guess what will happen next. And what will happen next is that I'm going to apply something as customized defined in customize-other/base directory. I'm applying a different application right now to that workspace in KCP, in the logical cluster, right? Control plane cluster, call it whatever you want within that workspace. And let's go to the other tab, the one that contains K9's dashboards for both clusters, and see what's going on. Look at that. Look at it. Two new pods were created in both of the clusters. KCP instructed 2 clusters because I bound those 2 clusters to that workspace to apply the manifest deployment service and so on and so forth. And we got, among other things, pods. They're not yet running, at least not in the staging, but it will run in a second or two. Now, there are other things and features of KCP like sync targets and locations and placements. You can go through documentation and learn the terminology, but what you saw is what really matters. And that's, let's talk about it actually next. Let's see what really is KCP or what it could be. KCP describes itself as a control plane for Kubernetes clusters. Not necessarily for everything, but for Kubernetes clusters. And that description suits it well. But, there is always a but. It does not paint the whole picture. As a matter of fact, I see it more as a beginning of the next phase of Kubernetes. Still, I do need to give you a bit of context first. So, here it goes. Here's the context, and then we'll go back to KCP. Kubernetes is not only about the ability to run containers across a fleet of servers grouped into clusters. It is a lot more. Kubernetes is supposed to be a base platform not used directly, but extended into whatever we might need. That is accomplished through its extensible API and controllers behind those extensions. Kubernetes is, first and foremost, supposed to be a control plane to manage resources, no matter whether they are containers, infrastructure, services, applications running on VMs, or anything else. And we see that through the emerging number of projects that leverage those capabilities. We have KubeVirt that uses Kubernetes to manage VMs. We have Crossplane that uses Kubernetes to manage any type of resources, no matter whether they're containers, VMs, infrastructure, databases, or anything else. We have many others, but today I focused on KCP. KCP proves that Kubernetes can be so much more than what we think it is. It's hard to describe what it is, and I feel that the community behind it is still trying to figure it out. So I have my own preferences that might or might not be in line with what the community is trying to achieve. I feel that KCP can be a great candidate for at least two use cases. It's about making a tailor-made Kubernetes cluster that, first and foremost, primarily serves as a control plane to manage other clusters and resources. And that's what you saw in the demo. But it is also about having a specialized Kubernetes cluster that is dedicated to specific tasks instead of being a typical generic Kubernetes cluster that does everything and might at the same time be inefficient. Okay, actually, maybe KCP itself is not about having specialized clusters, but it certainly shows that it is possible and very likely. Just as we have specialized operating systems, we can have specialized Kubernetes clusters. Projects like Crossplane, Averno, Argo CD, and quite a few others might benefit greatly from a project like KCP, or at least the ideas behind it, if not the project itself. Now, if I'm right, we'll see more and more SaaS solutions built on top of KCP or some other tailor-made Kubernetes distribution. If you need to provide a service backed by your projects, KCP is one of the best, if not the best candidate to be the building block of such a solution. It is very lightweight, it has multi-tenancy built in, and it can be fine-tuned to specific needs. Actually, I don't think we'll see much of KCP from now on. Instead, I believe that we'll see more and more services built on top of it, and we as users might not even be aware that KCP or something similar to it is powering those services. It might end up with the same fate as hypervisors. Almost no one uses hypervisors directly, and many do not even know that they exist. Yet a massive number of services are built on top of that. Every time you create an EC2 instance, you're using a hypervisor. Every time you deploy a serverless application using Google Cloud Run, you are using a hypervisor. You don't see it, and you might not even know that it's there, yet it is crucial for many of the services we consume today. KCP or something similar might end up with the same fate. Some will think that such services are connected to a normal Kubernetes cluster, but in reality, they are or they will be connected to something like KCP. Others might be consuming a SaaS solution that is built on top of it. KCP is one of the few projects that really and honestly impressed me with the potential. It is not perfect, but it's a great start. It does not look like much, but it actually is, or to be more precise, might become. Let's go through pros and cons and see what's good and what's really bad about it. And by the way, I like to start with cons. So let's start with bad things. The first thing is it has horrible documentation. But that's okay because it is in a very early stage. Docs are actually full of information, but it is mostly academic. You will not find any examples or tutorials, so be ready to approach it as if you're reading a scientific paper rather than something that will kickstart your journey towards adopting KCP. So docs is the first problem. The second thing is that propagation of events and logs from workload clusters to KCP is still missing. You will not see from the control plane KCP cluster logs or events, at least not yet. I think that that's coming, but it's not yet there. And finally, some features are finicky. Like Kubernetes get this and that sometimes works, and at other times it doesn't. Now, those are potentially serious problems, and there are quite a few others. But I must repeat, this is a very young, early stage project. So those are not really downsides, but the nature of having projects in early stages. Now, for the good things, for the pros, first of all, it is a control plane of sorts, at least. So if you need a control plane cluster to manage other clusters, this is a potentially great solution. Second, it has multi-tenancy built in. Those workspaces are ideal place for multi-tenancy that will be distributed, workloads distributed in other clusters. It is specialized. It does few things, but it does it well. And the last one is that it is a glimpse of where Kubernetes is heading, with extensible APIs, being a control plane, having specialized clusters, and so on and so forth. It's not only about containers. Remember that. Thank you so much for watching. See you next time. Cheers.